Today is Tuesday, November 12th, and we are working on Module 2, Lesson 19, okay? As you know, we're headed to tomorrow, we're going to do 20 and 21 combined, and then on Thursday, we're going to do 22 and 23 combined, okay? And we are heading into a section of 5th grade math that I have to be honest with you is my least favorite section. And the reason for that is because we're going into two-digit division, okay? And two-digit division isn't only hard for me to say out loud right now, but it's also tricky. It's not hard, but it requires a lot of estimation and number sense in our brains, okay? It requires us to do a lot of guessing and checking. It requires us to do a lot of multiplication, and sometimes we'll find that we do some multiplication and our answer that we originally thought was right wasn't right, and we have to try it all over again. It fills the page. This is the kind of math, two-digit division, is the kind of math that fills a page with calculations, okay? And that's why, personally, I don't like doing it. But it is important. It happens in everyday life, and it's a skill that you need to know, okay? So you're going to have to bear with me. You're going to have to be patient with yourself. Sometimes this math is just, it's not hard. It's just cumbersome or tedious or, to be quite honest with you, annoying, okay? Because there's a lot of calculations. Buckle up, you can do it, okay? And today we're not quite there yet. We are laying the groundwork. Today's skill, dividing 2 and 3-digit numbers by multiples of 10, is what's going to be really helpful for you as we move forward into the rest of the math this week, okay? As you know, in real life, do we always divide only by multiples of 10? No, we can divide by any number, 84, 102. 76, right? But we're going to take a simplified approach today to kind of introduce us to the idea of dividing by two-digit numbers by first using multiples of 10, okay? So today we're going to divide by numbers like 10 or 20, 30, 40, 50, 60, 70, 80, and 90 because those are the two-digit multiples of 10. Make sense? Okay. Okay, whenever we're doing division by a two-digit number or a three-digit divisor or four-digit, whenever a divisor is more than one digit, we're going to follow this method. Estimate, repeat after me. Estimate. Divide. Check. We're always, listen to me, we're always, estimate, divide, check. Say those 3 words.
Estimate, divide, check.
Very good. Go ahead and copy down 70 divided by 30. What is our whole?
70.
What's our divisor?
30.
What's our quotient?
Don't know yet.
That's what we're trying to find. Good. When we estimate, we know how to do that. That's what we did last week, yeah? So you can see last week when we were learning to estimate, it was really setting us up so that we could do the first step of dividing by a two-digit number, which is estimate. When we estimate, what do we round first? The divisor or the whole?
Divisor.
Okay. Do we need to round our divisor?
No.
No, it's already a nice round multiple of 10. So we're going to keep it the same. Is 70 compatible with 30?
No.
Is it?
No.
What is close to it that is compatible?
60.
So we're going to think 60 is closer than 90, right? So let's go 60. Okay. 60 is divisible by 3, which means it's divisible by 30. And so I can think of this. How can I expand this out if I forget about units? Maham?
You can do 6 tens.
60 divided by 10?
Yeah.
Divided by 3?
Yeah, divided.
Oh, good. What's 60 divided by 10?
6.
So this is the same thing as 6 divided by 3, which is? Okay. Is 2 my final answer? No. It's my estimation. And estimation is helpful because it tells us around where our answer will be. Okay? You're going to see why it's really helpful in just a second. Now let's actually divide. Who's our whole living in the house?
70.
Who's the divisor knocking on the door? Okay. Let me just tell you something really quickly. A very common 5th grade mistake is that when they're setting up, after they've estimated, 5th graders will set up their division problem using the standard algorithm. But instead of looking back at what the real problem is, they'll write their estimation problem. They'll write this. 60 divided by 30 equals 2, and 2 is my final answer. Now that is not the question we're asking you to solve, okay? So please don't do that. Look back to see what your real whole is and what your real divisor is. Okay, because we estimated, we know the answer should be about 2. So let's try that. Dad's going to divide, and he always likes to use our estimation to help us. So when Dad divides, he's going to try 2, because when we estimated, we told him the answer is going to be close to 2. Mom needs to do what next?
Multiply.
Mom needs to do what? Multiply. Good. What two numbers will Mom multiply?
2 30.
2 times 30. We can actually do that in our head. If we couldn't, we would write it out, right? Okay, this is what I'm saying. But can we do it in our head? Yeah, but I'll write it out anyways. What does it equal?
60.
Okay, then sister's going to do what?
Subtract.
And so what do I have left?
10.
If I have 10 without regrouping, if I have 10 ones without regrouping, can I divide it into 30 equal groups? No, right? I don't have enough. So today and this week only, stay tuned for future news. I don't know about future, but for this week, we are going to use remainders. My remainder is 10 because it is less than my divisor, right? And so that means that I cannot divide those 10 remaining pumpkin seeds or whatever they are, right, into 30 equal groups. So I write an R and then the number, okay? What is my quotient?
2.
Good. What is my remainder?
10.
What is my full answer?
2 remainder 10.
Good. You guys heard me talking to 4th grade. 2R10 is not my quotient. The quotient is 2, and the remainder is 10. That means I have 10 remaining, okay? Now, how can we check our work? You guys, we know that now our answer is 2, remainder 10. We know about zipping and unzipping, right? Inverse operations. What is the inverse operation of division?
Multiplication.
Multiplication, good. So what that means is if I divide going this direction, I should be able to unzip using multiplication. So I can do 2 times 30.
Plus 10.
Nope, 2 times 30 equals 60. But then I had 10 remaining, right? So I have to take the 60, and if I add 10, what do I get? 70. Is that what I want to see? Yeah, I want to end up with my whole. Just like I told the 4th graders, here is an inaccurate way to write this. 2 times 30 equals 60 plus 10 equals 70. Why is that inaccurate? Well, because let's read what we wrote. We wrote that 2 times 30 is equal to 60 plus 10. Is it equal? No. Okay, so we cannot write it like that. We have to write it as two separate equations. Make sense? Good. When I'm doing my check, it's like I'm taking my whole of 70 and splitting it into two parts. 60 and 10. And 60 is the part that is divisible by 30, and this is why we're doing 2 times 30 equals 60, and then we add 10. Make sense? Good. So Dad is going to, again, take our estimate, right? I'm going to write down my real divisor, my real whole, which is 572, divided by my real divisor, which is 90. Dad's going to take my estimate, so I'm going to put a 5 in the ones place. Mom's going to multiply 90 times 5. I'm going to write it down because I always have to record my math thinking. I know that's equal to 450. So I'm going to subtract 450. 2 minus 0 is 2. 7 minus 5 is 2. 5 minus 4 is 1. So my remainder is 122. My answer is 5, remainder 122. A lot of you are shaking your heads. No? This is not right? Talk to each other. What's not right about this? In this example that I purposely tried to make, and you were all along, you're like, Miss O, no, this is not right, this is not right, was to show you this. If our remainder, 122, is larger than our divisor of 90, what does that mean? Could I have put one more in each group? Yes. So rather than only put 5 in each group, I really could have put 6. And this is something that you might run into sometimes where you do math work and you're like, oh no, that turned out that was not right. That means that 5 was too little. So instead, I should try 6. And I'm going to, again, write out my math. 6 times 90 is 540. And so I'm going to subtract that this time to get 32. Is that better? Yes. Because we need our remainder to always be smaller than the divisor. If it's bigger than the divisor, it means we could have put one more into the quotient. Okay? So the answer is 6, remainder 32, I think, but I need to check my work. I can check my work by doing 6 times 90, which is equal to 540, and I can do 540 and add 32 more, which is 572, and that is my whole, so yay, I am happy.